Myself, Naveen Kumar, and here I am conducting a seminar on camless engines under the guidance of Suraj Vasant Yadahalli sir and Dr. Edward Basaras, sir, HOD of Mechanical Department. Here comes the contents. Introduction part, working, methodology, structural view, advantages and disadvantages, results, conclusion, and reference. Here comes the introduction part. The new emerging technology for automotive technology are the camless engine, which the engine does not have camshaft to lift the both intake and exhaust valve. In the diagram, we can see electromagnet, armature, curbs, springs, and valve. When it comes to the cams part, control the breathing channels or valves of an IC engine connected to camshaft, which is operated by crankshaft. Cams push open valves at proper time and guide their closure, but they are inflexible except VTEC and VVT1. Engineers could not vary timing, lift, and duration of valve opening infinitely. Camless engines. Eliminated mechanical linkages could provide infinite variation of valve parameters. It can make engines clean, efficient, and responsive. Working of conventional engines. The crankshaft turns camshaft, which operates valves by mechanism. Spring brings back valve to initial position. Timing of engine valves depends on shape of cams. And here are the diagrams of conventional engine valves, where we can see valve racker, camshaft, sintered alloy chip, pivot, hydraulic lay, adjust. Engineers must design cams in the development stages. This design compromises BN, engine power, and fuel efficiency. Considering this compromise, automobile companies brought variable valve timing mechanisms, but its effects were limited. Camless engines overview. Main sensors: engine load sensor, exhaust gas sensor, valve position sensor, engine speed sensor. Sensors directed to the electronic control unit and directed to the actuators. Sensors sense parameters and send signals to ECU. Electronic control unit contains microprocessors with associated software. This ECU controls the actuators to work according to requirements. Actuators. It is a electrohydraulic camless valve train (ECV). Uses elastic property of compressed hydraulic fluid, which acts like a liquid spring, accelerates and decelerates the valves. Hydraulic pendulum, which it involves conversion of potential energy to kinetic energy and back to potential energy with minimum energy loss. During acceleration of valves, potential energy is converted to kinetic energy. During deceleration of valve, energy of moving valve is returned to fluid. And here the detailed view of hydraulic pendulum, where we can see high pressure check valve to and from high pressure source, low pressure check valve to and from low pressure source, high pressure solenoid, low pressure solenoid. Operation of hydraulic pendulum. In step 1, where we can see opening acceleration with high pressure solenoid is activated, we can see crank angle. In step 2, which it comes opening deceleration, where we can see low pressure check valve is open with some crank angle and lift. In step 3, valve fully opens. Both solenoids and check valves are closed. In step 4, closing acceleration. Low pressure solenoid is activated. In step 5, closing deceleration. High pressure check valve is open. In step 6, valve seating. Low pressure solenoid is reactivated with some crank angle, where we can see the curve. Lift, timing and duration of valve opening is varied by controlling solenoid valves. This is done by electronic control unit when signals are sent from the sensors. Here is the modifier rod used to impart unequal lift to the paired valve, zero motion to any valve. In the diagram, we can see high pressure solenoid and low pressure solenoid. We can observe control chamber, high pressure check valve, low pressure check valve, to and from high pressure source, to and from low pressure source, and unequal lift modifier. And here shows the three figures which it shows modifier rod operation. Figure A, which it has valve 1, valve 2 with communication chamber with high pressure reservoir. Here comes advantages. Enables the development of higher torque throughout the entire reverse range, which in turn improves fuel economy. Cylinder deactivation can be achieved during the idling phase. Exhaust gas recirculation is improved, reduces friction losses, reduces the inertia of moving parts. When it comes to resultant advantages, better fuel economy, 7 to 10% increase, higher torque and power, 10 to 15% increase, lower exhaust emissions, EGR system is eliminated since EGR effect occurs on its own and thus reduces NO emissions, reduction in size and weight. Disadvantages: high cost, increased power consumption, air gap between the solenoids may demand a higher magnitude of current during certain periods. The control strategy for valve seating velocity needs to be modified. And here comes the conclusion. Even though some disadvantages are present, we can expect electro-hydraulic and electromechanical valves to replace the conventional camshaft technology. And here are the references. Thank you.